All right. People are starting to come in. Hello, everyone. How is everyone today? If you can hear me okay, can you please just type a yes in the chat so that I know that you can hear us all right? Excellent. Yes. Wonderful. Okay. My name is Erica. I am one of the children's librarians here at the Berkeley Public Library. And I just want to remind you that this program is being recorded. So if you have to leave for any purpose or anything like that, you can always come back and watch it later. We are going to have the recording up hopefully by the beginning of next week. Again, my name is Erica. I am one of the children's librarians here at the Berkeley Public Library. And Berkeley, California is within Ohlone territory, the traditional lands of the Ohlone people who still live and work and play in this region. There are over 562 federally recognized Native American tribes in the United States currently, and we want to make sure to acknowledge the original inhabitants of this land. Before we get started, I just want to let you know about some upcoming programs. So this program is the first for our Women in STEM series. S is for science. So T is for technology. And so next month, on April 16th at 3:30 p.m., we will have a student success specialist and 2 apprentices from Bitwise Industries, and they work in technology, and they're going to talk to you about what got them interested in technology, what do they do all day, and then they're going to lead us in an activity, just like we have Pinkie here to do today. So I normally would say, let's give a big round of applause, but we won't be able to hear you. But we want to welcome Pinkie Young, who is a geologist from the Lawrence Hall of Science. We're so excited to have her here today and really excited to hear what she has to say. Oh, and I just want to let you know that behind me, there are some books here all on the earth, geology, experiments, rocks and minerals and crystals, and a Super Earth Encyclopedia. And there's these books and much more that you can get at the library on the subject of geology. And now, without further ado, I'm going to turn it over to Pinkie.
Woo. Thank you for that, Erica. And hello, everyone. I am so excited to be here to talk to you all about what I do. My name, again, is Pinkie Young. Thank you for joining us and being a part of Berkeley Library's Women in STEM program. I am a geologist and educator at the Lawrence Hall of Science, and I'm super excited to talk to you about what I do, my field of study. I'm going to show you a couple of cool rocks from my collection. Of course, every good geologist has a very good rock collection. And I'm also going to show you a small crystal growing experiment that you can do at home with an adult. Now, if you have any questions about rocks or about anything that I do, feel free to put them in the chat. And I will be answering, we'll have time at the end of the program to answer questions. Now, I have a question for people. Since I teach classes online and I usually get to see people's faces, but since this is a webinar style, you will have to use the chat, but there's also a function that I want you guys to try and find. It's called the raise hand function. So with the raise hand function, could you answer this question for me? Who has heard of the Lawrence Hall of Science before? And if you've heard, the raise hand function is working. All right, nice. Awesome. It seems like a fair amount of people have heard of the Lawrence Hall of Science before, which is awesome. The Lawrence Hall of Science, if you haven't heard of us, we are UC Berkeley's Public Science Center located on the top of UC Berkeley's campus. Our activities mostly focus on hands-on science. I love seeing my students explore their curiosity with our hands-on science activities because that's how I got interested in science when I was a kid. So I have a question again for you all to answer in the chat. So you can go on ahead and lower your hands now, lower your virtual hands. So I have a question for you all to answer in the chat. So marinate on this question for maybe 10, 20 seconds. what is something that you're curious about? I'm curious to see, what is something that you are curious about? Go on ahead and type your answer in the chat because I want to learn a little bit more about the people that I am talking to today. Ooh, finding fossils, that's very cool. I'll give friends maybe 15 more seconds. What is something that you are curious about? Ooh, awesome. The solar system. Very awesome. These are some great responses, y'all. Animals, yes, animals are very cool. Everything, I'm sure that is a very exciting life when you are curious about everything. Wow, everything is just so exciting. Sloths are very cool. All right, thank you for answering, my friends. The reason why I ask, what is it that you are curious about, is because I actually got to follow my own curiosity and study what I was curious about in college. So I got to study rocks. When I was a kid, I loved rocks, and I guess I still do love rocks. So I loved picking up random stuff when I was a kid. I grew up in the Bay Area, so my mom took me to a lot of parks, and I picked up a lot of random stuff, sticks, flowers, but especially rocks. I don't know if you've looked at a rock lately, but they're pretty incredible. No one rock is the same. They come in all sorts of different shapes, sizes, and colors. And a great segue into the first couple looks at my rock collection. So this is a pretty exciting one that I think is super cool. This is a blue rock, and it's called azurite. I'm not sure if you can see on my camera, but it's actually super duper sparkly, so it's bright blue. So this is one type of rock. Another one, just because I do love sharing my rock collection. This is a fossil, since a lot of people in the comments said that fossils were very exciting. This is a trilobite. And this trilobite is, actually, I'm gonna have you all guess. How old do you think this trilobite is? Maybe take 5-10 seconds to think about it. How old? How many years old do you think this trilobite is? I'll have you answer in the chat before I reveal the answer. Okay, 50 million years old, interesting. 50 years old, okay, 300 million, 35,000, awesome. I will tell you all that this trilobite is 345 to 400 million years old. 400 million years old. That's so old. So rocks, I have a bunch of them that I love looking at. I find them very interesting because they're all just so different from each other, even comparing this blue one to this animal. And they're both considered rocks. So when I grew up in the Bay Area, my mom took me to a lot of museums like the Lawrence Hall of Science. My favorite part of the Lawrence Hall of Science, where I was probably the most curious, is an area called Forces That Shape the Bay. Now allow me to share my screen one more time. There we go. Next slide. Here we go. This is the Lawrence Hall of Science, and this is the area called Forces That Shape the Bay. I still, to this day, remember playing at this exhibit and wondering why certain rocks look the way that they do. As you can see outside, there are a whole bunch of big pieces of rocks. There's also a big pond where you can play with the water. And I was always wondering, why do certain rocks look the way they do? Why does this rock look so green? And there were rocks that looked like this outside of Forces. Why is that rock shaped like that? Did it form naturally, or did somebody cut it up so that it looked like that? So as I said earlier, when I was in college, I got to follow my curiosity and I studied rocks and how they are formed in our Earth. And this field of science is called geology. So the study of rocks in the Earth's crust and the history of the Earth. I think we have a lot of rock hounds in the comments. So I wonder, there are 3 main groups of rocks on our Earth. I wonder if anyone can name one in the chat. I'll give you all 15 seconds. I wonder if you can name one of them. in the chat. Ooh, nice. Very nice. So we have igneous and sedimentary. Ooh, Danica in with all three. Very nice. Sedimentary, igneous, and metamorphic. Y'all are pros. That's awesome. Well, a quick rock cycle rundown. There are three main types of rocks, as you are all really, so many good answers in the chat. There are three main types of rocks on our Earth: igneous, sedimentary, and metamorphic. Rocks are constantly changing in what's called the rock cycle. It takes millions of years for rocks to change from one type to another. There are, number one, igneous rocks, which form from volcanoes. Then there are sedimentary rocks, which are made from smaller pieces of sediment or smaller pieces of rocks that have built up and hardened over the years. And there are also metamorphic rocks, which are somewhere kind of in between. Rocks that have formed but have been changed or metamorphosed by the pressure and heat from the Earth. Today, I'm only going to talk about one very specific type of rock, and I'm going to be talking about igneous rocks. So this was my, yep, exactly. Rua in the comments, obsidian is a type of igneous rock. That's totally correct. So my area of study involved igneous rocks. Now there are two types. Ooh, which type has crystals in it? I see that question in the chat. That is an excellent question, and I think I have an answer for you. There are actually two types of igneous rocks. So there are those three main types, and then within that, you can get even more specific. So this is a picture of a volcano, and there are two types. Ooh, interesting question from Emily. I will answer that later. But there are two types. Give me 1 second to find my notes. Oh, right. The ones that erupt onto the surface of a volcano, like think of Hawaii. And those are called extrusive rocks. They erupt onto the, oh, sorry, I'm just taking a look at the chat. It's a little bit distracting as a presenter. Thank you all for your patience. So what I'm really interested in looking really close at the crystals in igneous rocks. So we have extrusive rocks, which explode onto the outside of the volcano. And then these are the ones that I'm interested in. Intrusive rocks, the rocks that form inside of a volcano. So first they form inside of the volcano, and then they are brought up through Earth's tectonic activity. So those types of rocks look a lot like this. And I think we had a question in the chat, which type has crystals in it? Intrusive igneous rocks are the kinds that have crystals in it. They usually look something like this. This is a rock called diorite, and this is a rock called granite. All those little flecks on the inside, those pink flecks, black flecks, the white flecks here, those are all different crystals. And I have a question for people. Can everybody see my slides? Go on ahead and type yes in the chat if you can see my slides. Okay, cool, just making sure. Thank you, my friends. All right, so all of those different colored speckles are crystals. Now they're not big crystals, but they are crystals. So my research involved looking at these intrusive igneous rocks under a microscope to identify what conditions the rock formed in. Now you may have used something that looks like this to take a look at rocks. So this is a hand lens, and you can get a really close look at things in your hand. So for example, holding a rock, I can take a really close look at the surface of the rock. But in my research, I use a very special kind of technique to look through rock. So right now it's kind of hard, actually impossible to see through this rock. But in my research, I was able to do that using a very special technique. This is a method of geology called petrology. So I'm going to show you a couple more slides of how I can actually see through a rock using a microscope. as opposed to a hand lens, looking on the surface versus looking through the rock. So the way that geologists do this, there we go. The way that geologists do this is step one, find a nice rock that you would like to look through. You attach it to a glass slide and slice it down to size. The next step is with that rock on the slide, you grind it down to about 30 microns. Now, a human hair is 50 microns. So if you grab a piece of your hair right now and rub it through your fingers, that's about 50 microns. These thin sections of these rocks are thinner than that. They're about 30. So almost half as thin as a human hair. Now, when you are done grinding down your rock sample, it looks something like this. So you have your main rock, then you have your piece of cut rock. And once it's ground down, it looks like this. Now we can put it underneath a microscope to take a look at the crystals inside of that rock or inside of that thin section. And you may be asking, what does it look like under a microscope? Now it's kind of black and flecked a little bit. So I wonder, what does that look like under a microscope? Now here is a video of a mineral called muscovite under a microscope. And this is my favorite part. As you turn the slide, some of the crystals look like they're blinking. And you may also notice the video go from colorful to clear, just like that. That is caused by a switch on the microscope. Turning it on shines a special type of light through the slide called cross-polarized light. So when you turn the switch on, that's when you get the very colorful, beautiful, blinking minerals in your slide. When you turn it off, it's basically like looking at the slide in regular light. And like I said earlier, this is my favorite part of my research. I think it is so beautiful, the different colors of the crystals that you can see. And not only is it very beautiful, every mineral in a rock has its own crystal structure, and it makes it look different under the microscope. By making careful observations of the color and the shape of the crystal underneath the microscope, geologists can figure out things like how hot the magma was when it formed and how much pressure it underwent as it cooled. Here are a couple pictures of the slides that I worked on in my research. Let's see if it'll go. I think I might have to manually do it. There we go. So these are pictures that I took with actually my iPhone, if you can believe that. These are pictures that I took with my iPhone on my microscope when I was doing my research. So looking at these slides, looking at these very, very thin sections of rock under cross-polarized light, we can figure out what kind of mineral is in, or what kind of crystal is in each rock. So for example, allow me to, let's see if I can turn on my pointer. Oop, there we go. Thank you, Google Slides. So in this middle one, this is one of my favorites. This is a mineral, so I can see from the shape and the color, this is a mineral called hornblende. And the one right next to it looks super different. It's black and white and has these very interesting striations or streaks on it. That is a mineral called, I think it's plagioclase feldspar. I would have to double check, but it is a mineral, definitely feldspar. And by taking a close observation of how the grains are next to each other, you can figure out what type of conditions the rock was when it formed, like how hot it was, how much pressure it was going under when it was forming. And in my research, I was looking for very fresh contacts. So for example, like this line, these crystals next to each other are super duper fresh. That's the best term that I can come up with to describe what I was looking for. So very fresh contacts. In some rocks, you'll find that it looks a lot more crunched up. I think you might have seen a little bit of that in the video, but mine were very fresh contacts. Alrighty. I think that's the end of my slides for right now. And thank you, Erica, for providing tech support. Appreciate you for that. So I was looking at crystals in my rocks, but the question is, what causes crystals to form? Now, there's actually a very useful formula to talk about crystallization. So the crystal formula. So in order for a crystal to form, whether that be in magma or with other things in other items in your life, there's a crystal formula that you can follow in order for a crystal to form. So in order for a crystal to form, you need three things. You need heat, you need supersaturation, and you need time. Now, heat, in a volcano, you do need the magma to melt down in order to reform crystals. So you can't really do much. Crystals can't really form in an already cooled off rock. It does have to be kind of hot. Number two, supersaturation. So when liquids are hot, they can dissolve more material than when they are cold. So think about putting sugar in cold water versus in warm water. It definitely does melt down a lot quicker in the warm water. So when the liquid cools, the material gathers together to form a crystal. So in a volcano, magma is so hot that it's considered a liquid. Insane to me. They also need time to cool slowly. Time to cool slowly, excuse me. Bigger crystals take more time to grow. Bigger crystals take more time to grow. I think of this in terms of like laying in bed. So when you lay in bed and you are feeling really nice and cozy, if you have to get up really quickly, think about how you feel when you get up super quickly. Not super duper rested. You kind of feel a little bit groggy, like, oh man, I really wish I had more time. When you have more time to sit in bed and be all cozy and nice, when you get up, you feel a lot more well rested. So I like to think of that analogy in thinking about time for crystals. So crystals need a lot of time to cool slowly for them to grow a lot bigger. I'll put the crystal formula down for a second. Now I have a quick quiz for you all. I'm gonna pull out 2 rocks from my collection, and I want you to tell me which one cooled fast and which one cooled slow. So remember, bigger crystals need more time to grow. So they cool off really, really slowly. Smaller crystals are cooled down so fast, they don't even get a chance to become big and beautiful. So I have 2 pieces of muscovite from my collection. Muscovite is actually the same mineral that we looked at in the video that I showed you earlier. So this is actually the same mineral, but in my hand. So I have this piece that I'm going to say is in my left hand. So left hand piece, and I have this piece that's in my right hand. The muscovite is the super shiny part on the edge there. So I want you to tell me, left hand piece, did this one get more time, or right hand piece, did this one get more time? And let me turn on my chat because I actually do not have it open. So left hand piece, right hand piece. Left hand more time, right hand more time. Okay. Lots of people are saying the left hand got more time to cool, and it did. So this piece is actually very, very large. The black part is not part of the muscovite, but this piece is a very large piece of muscovite, and it got a lot of time to cool in order for it to form that big. So you all did a wonderful job with my pop quiz. So those are the 3 things that you are going to need in order to grow a crystal, whether that be in a volcano or at home. Now, you don't need a microscope to make observations of how crystals form. Geologists use microscopes in more advanced studies of rocks, but you can actually make crystals at home without magma. There's a whole bunch of crystalline things in your home that are hiding in plain sight. Two of them we use to season our food. So I wonder if anybody can take a guess. What are some things that we can use to make crystals that are in our home? Pepper crystals. I should try that one day. It's an awesome answer. Are my earrings crystals? They are not. They're actually sushis, and they were made by a very, very cool person. And I see a lot of people saying salt and sugar. Salt and sugar. Nice. So those are the two main ones that I think of when I think of crystalline things that we can use in our home that we can use to make bigger crystals. So today we are going to use sugar and the crystal formula, and I'm going to show you how to make Geologist rock candy. Now you might have made rock candy before, but I have a couple tips and tricks that I'm gonna pull from the crystal formula in order for you to make the best rock candy you can. Geologist rock candy is special in that we can use what we've learned about crystals today so far to make really, really big crystals. So rock candy is awesome, but even more awesome when the crystals are bigger. I am going to transfer you to my experiment area to show you how to make Geologist rock candy and what you're going to need for that. If you are like, oh my gosh, I need to write down all of the amounts that she's going to use, don't worry. Erica is going to send you an email with the amounts of sugar and water that I'm going to use and the directions for how to actually make this rock candy. Allow me to switch you over to my area. Now, I'm not going to pull out my whiteboard just yet. Does anybody remember the first part of the crystal formula? What do we need first? And I'm going to give you a little hint by turning this up and also taking away my coffee mug. All right, y'all are really paying attention, and that's awesome. So the first one is heat. So I am going to take my hot plate and heat it up so that my water starts to boil. And let me take off this top. And as it starts heating up, I'm going to tell you all of the things that you're going to need to do the thing. Now here I have a beaker. You could also use a stove and a pot. That is actually how I did it the first time. So I have a beaker here with about a cup of water. And for the sake of time, I already dissolved 1 cup of sugar into this beaker. And before we get started with the actual experiment, I'm going to have you choose what color my rock candy is going to be. So another thing that you are going to need if you would like your rock candy to be colorful is food coloring. Now I like using gel food coloring the best. It just seems to work a little bit better, but really any food coloring is going to work. All right, so I'm seeing some pinks, some blues. So go on ahead and put that in the chat and I will choose one randomly once I go through all of the materials that you're going to need. So food coloring, you are going to need a bit of sugar. In here, I have 2 cups of sugar. For this recipe, you're going to need 3 cups of sugar. I did prepare one thing before our presentation today. I did prepare these sticks. So these are skewers that I dipped in water and then I dipped in sugar. I'm not sure if you can see the sugar on the edge of the stick, but I dipped it in sugar because I want my crystals to start growing on my stick. So those sugar crystals are going to be a place for the sugar crystals to start forming. You will also need something to mix your mixture with. I have a little baby spatula. And I also have a piece of foil here. So my mixture is still heating up. As you can see some of those little boiling bubbles on the bottom. I'm going to wait for those to get a little bit bigger before I start pouring my sugar in. So the first step, as many of you said so expertly in the chat, we're going to need heat. The second thing that we're going to need is a super saturated solution. I'm going to pull out my whiteboard once more. A supersaturated solution. So we're going to need to put a lot of sugar into our water. When our water heats up, it can actually melt down more sugar than when it is cold. So we're going to heat up our water here in order to make it so that we can supersaturate it. If it's just cold, you can't get as much sugar into the solution. I'm going to turn it down a little bit, and I'm going to start adding my sugar. And I think I've run over just about everything that we're going to need, except for the container that I'm going to put my sugar solution into. So I'm going to add a little bit of the sugar. And what I'm looking for when I add my sugar, so I'm going to add about half of it right now. Cool. And as you can see, I'm not sure if it's super clear on camera, but once I added my sugar, my water became really cloudy. So what I'm going to do is I'm going to stir, stir, stir until my water is clear again. I could actually see some of those crystals. We're going to melt down all of those little sugar crystals into my solution. Maybe turn up the heat a tiny bit more. And I'm going to take a look now at the chat and choose a color. I'm seeing a lot of pinks. I'm seeing a lot of blues. So I think I'm going to meet in the middle and make it purple. Thank you all for choosing a color for me. So I'm going to add a little bit of my blue food coloring and then a little bit of my red food coloring. And hopefully we will make a nice purple. Let me stir that up first. And friends, if I did not choose your color, I apologize for that, but you can always make your own rock candy at home. And you can choose to make it whatever color you would like. Let's see. That looks quite purple. It does look a little bit dark on my camera, but trust me when I say it is purple. And a little tip for y'all that are going to try this experiment at home, you're going to want to make your solution, as far as the colors go, really, really dark, because when the sugars start to clump up on your stick, the color actually isn't going to be as dark as what it looks like in your solution. So feel free to, it looks a little bit dark. I see in the chat, I trust you. I appreciate that, Alex. Thank you. I'm going to make mine actually a little bit darker because when I stir it, it still looks a little light. So when you do this at home, feel free to really put a lot of food coloring, not the entire container, mind you, but feel free to put a fair amount in there. Now I'm going to pour the rest of my sugar in because I think the sugar that I poured in first is actually all the way melted. There we go. And I'm going to give this a nice stir. And I'm stirring until all of that sugar is dissolved. Now I'm going to let this sit for a little bit because I trust that it'll dissolve on its own now that I've given it a little bit of a stir. And now we can talk about the third part of the crystal formula. Does anybody remember the third part? We already have heat and supersaturation. Time, wonderful. And it is really hot, so we should not touch the beaker. I have, for when that time comes, I have a silicone glove. So this is very hot. As you can see, it is 500 degrees Celsius. So we should not be touching the beaker. If this is on your stove, do not touch a pot that is hot. And my friends that said time in the chat, yes, exactly. The last one is time to cool slowly. I have a question for friends in the chat. Let me move my food coloring to the side. Don't need that anymore. I have a question for friends in the chat. Now, I have two containers that I'm gonna make a choice which one I want to put my sugar solution into. But which one do you think is going to let my crystal solution cool slower? I have a glass jar, but I also have a thermos. So which one of these do you think would let me cool off my crystals slowly? All right, people are saying thermos. Some people are saying glass. All right, love to hear everyone's answers. I'll give peeps maybe 10 more seconds. If I want my crystals to cool down slowly, which one should I use? Ah, very interesting. I'm still getting a couple of responses in the chat, so I will give y'all a couple of, okay. Some people marinating on the idea and maybe changing their minds. Awesome. I'm gonna give this a quick stir. And then, all right, based off of most of your answers, I'm gonna use the thermos. This thermos is really good for both hot and cold liquids. So this thermos is going to hold heat for a very, very long time. While this glass jar is not going to hold heat for a very long time. This one is specially made for hot drinks. So I know it's going to hold my heat for a long time, really let those crystals snuggle in bed, get nice and big and beautiful. So I'm going to use my thermos. Now, I highly, highly, highly suggest, actually, almost a requirement, if you are a kid, definitely do this experiment with an adult, because this sugar syrup is really, really hot, and I wouldn't want to hear about anybody getting themselves burned. Now, my sugar solution, I think, it looks like all of those crystals are melted, so I'm going to cut off the heat really quickly. And now we're going to put everything together. So again, with my very fancy glove, because this beaker is incredibly hot and I wouldn't want anybody to get hurt, I'm going to first grab my beaker and pour my solution into my cup. And now I have a thermos full of hot sugar. It's filled to about here with my hot sugar. The next thing is I'm going to give my stick somewhere to hang out on, or somewhere to, so that it doesn't fall straight in. I'm going to take a double layered piece of foil that has a lot of sugar on it right now. Now it doesn't. A double layered piece of foil, and I'm going to cover my thermos with it. And the last step in making Geologist rock candy is, and as you can see, wow, this thing is really hot. It's still boiling even after I turned it off. And now the last step to make Geologist rock candy is to poke your sugar stick down through the foil. Now try your best to make it so that your stick doesn't stick to the bottom. I find that using a piece of tape is pretty good for this. But alas, my tape is nowhere to be found. So if you're poking your stick down to the bottom and you can feel the bottom of the thermos, you can lift it up and maybe stick a piece of tape to the top to make sure that it doesn't stick to the bottom. And I can show you why you don't want your stick to be on the bottom of your container. I had a bit of a failed experiment earlier this week. So this is the rock candy that I tried making earlier this week, and it the stick is at the bottom of my jar and I can't pull it out anymore. So all the crystals formed so well around my stick. It's formed to the bottom and really stuck to the bottom. So my friends, definitely try to pick your stick up, maybe tape it to the top of your container so that you do not have a rock candy that is holdable like this. Hopefully your rock candy will actually come out of your container. But one quick thing to show you. So I made another experiment in this thermos earlier this week alongside this one. As you can see, even though my experiment did not work out a hundo P the way that I wanted it to, we can still make observations of the crystals that ended up forming in the thermos versus in the glass jar. If you can see those crystals on the side, they're pretty small. Come on, camera, let's focus. Okay. But as you can see, all of those crystals are pretty small on the side, but I scraped out some of those big crystals from my thermos, and they're about this big. Unfortunately, none of them got the chance to stick onto the stick, but the crystals that actually grew from my thermos earlier this week did turn out to be quite large. So I hope you experience a bit more success in your geologist rock candy experiment. I believe thus ends the experiment. I have my rock candy ready to go. Now you will need, again, time. This is not going to form overnight. Crystals take millions of years to form in nature. This crystal is going to take about 1 to 2 weeks to form. And I'm seeing a couple of questions in the chat. I will answer those in a second. So you're going to wait about 2 to 3 weeks and or not 2 to 3 weeks, 1 to 2 weeks, not that long, 1 to 2 weeks. And make sure not to touch it. I know the temptation is there to, take a little peek or maybe see how your crystals are doing. I would highly suggest to maybe not touch them until all of the liquid has evaporated out of the thermos, and then you can take your rock candy out. And now I'm going to answer, I believe that is the end of my presentation. So I'm going to take a couple of questions in the chat. And I'm seeing Rua said, can we eat the crystals since we use sugar? Yes, you can absolutely eat the crystals. If you get an adult's permission to eat the sugar, you can absolutely do that. These crystals are edible. Have I ever looked at the candy under a microscope? I have not, surprisingly. I have not made a thin section of rock candy, but I'm super curious now to see if anybody has done that. I might look that up later. Thank you for asking that question. And why will the space between the stick and the bottom of the jar make a difference? Because the crystals are not going to, the crystals like space to grow on. So you want that space to be mostly on that stick. If you put the stick at the bottom of the jar, I believe that the crystals will also start forming on the bottom of the jar as well. And also just trial and error. It seems to work a lot better when you lift the stick up off of the bottom. Ooh, getting a lot of questions. I see one comment, I'm not going to eat the crystals. I saw how much sugar you put in it, and that is too much for me. That's totally, I respect you for that. And how does the water evaporate in a closed system with foil? That is actually a really good point, because that reminds me that I forgot to tell you one really important step. So we are expecting this foil to evaporate, or this water to evaporate within our system. But if you want it to evaporate a little bit cooler, you can poke a couple holes in the top. Because this foil is not super tight, it's not like a super seal, it will evaporate eventually when you when you just leave it. It might take a little bit longer, maybe around like 3 weeks, but it will evaporate eventually. So the water does have a way to escape, but if you poke a couple of holes on the top, it'll escape a lot faster. Ooh, some really interesting questions. How do geologists from RUA, how do geologists tell how old a rock is? And do geologists and archaeologists use the same techniques? There are many ways to tell how old a rock is. There's a bunch of chemical tests that you can do on a rock. So a lot of my research, we're first taking a look at those thin sections that I showed you, taking a look at the crystals and what they look like. And then from there, we can choose crystals to do tests on. So there's a lot, I think it's called uranium lead thermochronology, very long word, but there are a couple of different tests that you can do to figure out how old a rock is. It's a chemical test, so you would input the information that you have about the rock. And I used an Excel sheet in my research to figure out what pressures rocks formed at. Similar to that, you can use like a chart almost and figure out if there's this much mineral in this rock, it probably is this old. Or if there's this much blank, it's probably this old. And do geologists and archaeologists use the same techniques? That is an excellent question. I am not an archaeologist, so I'm not super knowledgeable about what kind of technologies or techniques archaeologists use. I do know that archaeologists, as far as dating rocks, I'm fairly certain that they do use a lot of the similar techniques, because a lot of sciences actually intermingle. So there's a lot of chemistry and there's a fair amount of physics involved. They probably do use similar techniques to figure out, you know, ages of rocks, for example. Alrighty, my friends. So it is 11:17 right now. So our program is starting to, or our program was supposed to end at 11:15. There are a whole bunch of questions in the chat. Thank you, my friends, for coming. Hopefully I can answer a couple more questions after, let you know a little bit of information. If you would like to know what the ingredients are for the rock candy, Erica is going to send out an email with a PDF or with a with instructions and with instructions for how to make the rock candy. What is the oldest rock that exists? I do not know, but I believe that Google knows. So I might Google that as well. Alrighty, my friends. Thank you so much for being so active in the chat. I really appreciate it. Okay, thank you all so much for coming.